Okay, good morning, everybody. In continuation to our Explore Combination Logic course, we will be discussing about ICs now. In previous lectures, we discussed about the logic functions, binary language, basic logic gates, and their truth tables. So after this topic about integrated circuits, then we will be moving on to the combination logic circuits. Combination logic circuits means that by joining or interconnecting two, three, four, five different gates, what kind of behavior we get, what kind of logic functions we get, and how they behave in a coordination. So based on their different combinations, we develop different uh, logic expressions, different mathematical questions or requirement which we want to do. We can do that by the logic functions, and the logic function can be performed by the combination of gates. We will look into that in our coming lectures, but today we will be discussing our electrical characteristic of a logic family. In any digital design, our primary aim is to create an integrated circuit. Integrated circuit, guys, if you search on internet or YouTube, if you want to see any videos about integrated circuit, you will find that this is a revolutionary electronic circuits that uh, we are able to develop a large number of electronic components on a semiconductor substrate and connect them together to form large circuits on a very small scale. So it's basically saving you a lot of space. You can say, so many components and circuits on a very small chip. So reducing the size, reducing the power consumption, increasing the performance speed and efficiency. These are the, you can say, the characteristic of integrated circuit. That's why integrated circuits are very popular. A circuit configuration or arrangement of circuit elements in a special manner will result in a particular logic family. Now, if we talk about the integrated circuits of logic family, means uh, we can make combination of different gates on an IC. Okay, on one IC, you can make logic gates in tens or hundreds or even more. As I told you before, that on one IC, you can embed, you can develop very large number of electronic components, and you can interconnect them to make certain electronic circuit which gives you a certain output. The same thing we can do with the logic gates. We can develop so many logic gates on IC, and they can perform the required function. Electrical characteristic of the IC will be identical. So ICs in both cases, they have the same characteristic and same properties. In other words, the different parameters like noise margin, fan in, fan out, etc. will be identical. What are these things? I will explain you in coming slides. So these ICs which are from the same logic family, they are compatible with each other. Means one IC series made by one company, it should be compatible with other companies' IC series, and you can connect them together because standardize the things. These are the basic classification of logic families. You don't have to really remember that, but this is just for the knowledge thing. So we will be discussing these further details. The bipolar families, they have these kind of ICs. Okay, diode logic, DL. In short, you will see the on every IC, you know that there is a part number written on that. That part number contains some alphabets and some numbers. So DL is basically mean by diode logic. So these are the ICs on which we are using various diodes to perform like AND gate, NOT gate, OR gate. As I told you before that all these logic gates are made from diodes and transistors. So that's why this is the diode logic. Transistor, resistor transistor logic, RTL, diode transistor logic, transistor logic. So there are different combinations. You can use basic component remain the same. And what are those basic components to make logic gates? Diode, transistors. So these are the different types of the bipolar family ICs for logic gates. Metal oxide semiconductor families, MOS families, they have all of these different types. Again, am telling you this is only for your general information. Okay, so there are different types, MOS families, or different types of logic gate ICs. So whenever you are choosing a logic family, uh, or whenever you are choosing any IC for logic gates, then for design purpose, you need to consider these important parameters. Okay, what are these parameters? That supply voltage range. So different ICs can need different voltage. Some may work on 5 volt, some may work on 3.3 volts. So unfortunately, we are not in the lab, but I could have shown you that in the lab we have two supply voltage available, because there are two different type of IC series. One works on 3.3 volt and the other one works on 5 volts. So depending on your circuit need, you can select the suitable IC, whichever you want, based on these criteria. Speed of response, how much speed of response means you give input and in how much time you receive the output. That is the speed of response. Power dissipation means power consumption, input output logic levels. So current sourcing, fan in, fan out, noise margin, all of these parameters you need to consider before selecting IC. These are the electrical parameters or electronic parameters. Parameter means properties of the ICs which you consider while selecting the IC. Okay, so the ICs, these are the details of the, development stages. The miniature low-cost electronic circuit whose components are fabricated on a single continuous piece of semiconductor material to perform the high-level function. What is this all about? This is about IC manufacturing. The IC is usually referred to the monolithic IC first introduced in 1958. IC is nothing new, it's very old. As you can see, in 1958, the first concept was launched. The IC are categorized as under small scale integration. Integration means summation. For example, you collect things together, it means you are integrating different things. So small scale integration has less than 12 number of gates. So if a small scale integration IC will have less than 12 gates, logic gates. Medium scale integration, 12 to 99 gates. Very large scale integration, 100 to 9,999, almost you can say 10,000. And very large scale, 10,000 plus. So as the technology developed, as we learned how to accommodate more and more components on a small scale, we developed very large scale integration ICs in which there are 10,000 plus logic gates. So IC packaging, it's not that important, so we will skip through this. But you can read it if for your general knowledge purpose. So, so these are the different, you can say, uh, different designs of the ICs. Okay, the same is shown here as well. Mostly we use these kind of ICs. They are easy to install on breadboard. So that's why we use these kind of ICs more oftenly in our lab. So this is called dual inline, because it has uh, two rows of terminals, one here and one on this side. So dual inline uh, ICs, these are most common. Flat pack, which is this one, and axial lead, which is this one. But most common we use this one. So these are the characteristic of digital ICs, the electrical or electronic parameters which we discussed before. Input and output voltage level. So high level input voltage. Remember guys, the ICs, they work on logic levels. As discussed before, the logic levels or the uh, binary levels, they are 0 and 1. Only two logic levels, 0 and 1. So that 0 and 1 in the form of electricity is defined by the voltage level. So for example, high level input voltage. This is the minimum input voltage which is recognized by the gate as logic 1. So how the IC will understand that I'm receiving 1 at my input or 0? How it will understand? It doesn't know any other language, binary, decimal, or any alphabet except the voltage. So the voltage level, it will decide by the voltage level. So next is low input voltage level. Low input voltage means logic 0. Okay, when low voltage is coming, IC will understand, or the gate will understand, that I am receiving 0. Okay, similarly, high level output voltage, it means uh, if the voltage is high, then it will understand that this is logic level 1. There are only two levels, 0 or 1. So the low voltage, it will understand that this is 0, and high voltage, it will understand that this is 1. Now what are those low level and high level voltages? Let me go to that relevant slide first. Okay, so keeping the things simple, that it's all about the playing with different voltage levels to recognize that any is it a binary 0 or is it a binary 1. So low voltage levels range, it will be 0, considered as 0, and high voltage level range will be considered as 1. And the same way the ICs behave at their input and output. So from here we will be continuing in our next session, which will start at 10:05. So I will stop the recording.